Hi everyone, Chris Wicklund here, meteorologist in the United States Air Force and a background in space weather. I figured today we'd talk about the 5/11/2024 solar storm, one of the biggest storms we've had in the last 20 years, the biggest one we've had in solar cycle 25, one of the biggest reports you've seen worldwide, possibly, based on phones and technology and people going out in the news. So yeah, it's gonna be a long video. We're gonna talk about data, we're gonna talk about reports, we're gonna talk about CMEs, the sun, so stick around. It's gonna be a long one. The sun is a complex entity that produces space weather in outer space. This can happen in multiple ways via solar flares, coronal mass ejections, proton events, electron events, and gamma rays. This activity on the sun comes and goes as it goes through periods called the solar cycle. These occur roughly over an 11-year time span with a 1 to 2 year break in between. The solar cycle is caused by the sun's magnetic field, which is the north and south pole, that begin to flip over the cycle's period and then repeats itself every time a new solar cycle occurs. When the magnetic field is flipping, the sun begins to sweat a little bit as it's doing work as the north and south pole are flipping. The sunspots are concentrations of the sun's magnetic field bubbling up to the surface and causing the dark spots you see here. This is a picture I've taken from August 7, 2024. Sunspots appear on the photosphere, which is the sun's surface. These spots can range from the size of Earth to large sunspot groups, which can span to the size of larger planets in our solar system like Jupiter. The larger sunspot groups tend to produce the most space weather. Sunspots were responsible for solar flares and coronal mass ejections. These are two separate events, but often get compared as the same thing in public spaces. What are solar flares? Solar flares are explosions of electromagnetic radiation. This can be normally seen as a bright star-shaped explosion on the sun, followed by radio blackouts that impact the HF spectrum of communication. Coronal mass ejections are where sunspots or other aspects release plasma from an explosive region, and the plasma escapes the chromosphere, then the corona, and in outer space. These plasma clouds carry protons and charged particles, along with a magnetic field that when it impacts a planet, example of Earth, it interacts and degrades the magnetic field. When the magnetic field is weakened, or what we like to call geomagnetic, particles are allowed to stream into the poleward regions and cause magnificent displays such as the aurora borealis. With all this knowledge, we can start to talk about the sunspot region AR13664. This group began on the far side of the sun into the last week of April 2024. Brighter regions called plage could be seen as it began to rotate onto the eastern limb. On May 1st, 2024, it would be designated as 3664. 3664 began as a small group with a couple sunspots. It did not look complex or capable of producing prolific solar events, but later in the rotation would prove wrong. From May 1st to May 7th, 3664 grew to about 3,000 to 4,000 millions of kilometers in size, which was showing its telltale signs of complexity and increase of sunspots. By May 7th, the group looked very spotty, with ring-like structures and frequent flaring, which was indicative that the region was quite unstable. On May 8th, 3664 produced its first 2 X-flares, and continued to produce 9 more before it rotated off the limb. These X-flares, alongside 40 C-flares and 61 M-flares, proved that the region was very active. Alongside flare activity, 3664 also produced multiple CMEs. At least 8 CMEs were launched from the period of May 8th to May 12th. These CMEs varied in speed and magnetic complexity, but due to being so close to one another, would be susceptible to combining into a term I like to call a CME smoothie. CME models were constantly being updated in days prior to May 11th, with very strong outputs. This video from a space weather forecaster on Twitter displays how many CMEs ended being modeled in the process. This was quite unprecedented. This led to a rare G4 watch, which was issued by Swipsy in preparation for this conglomerate of CMEs to impact on May 11th. They have not issued this strong of a watch since the 2000s. Around noon in America, or 15 to 16 UTC, a large impact was observed at our satellites at the L1 point. the BT-BZ field opened up and the magnetic field was susceptible to large impacts, from 40 BT to negative 40 BZ. This caused us to jump into immediate KP8 G4 conditions. Solar wind jumped to almost 700 kilometers a second and densities remained in elevated territory. Right after 21 UTC, an even more larger impact slammed into the satellites at L1, and our conglomerate of CMEs became even more geo-effective. The BT to BZ spread spiked into plus 70 BT to negative 50 BZ, which caused prolonged periods of KP9 G5 storming to ensue. According to the GFZ Potsdam data, which is a 30-minute KP index, it measured a period of time where it measured KP11. Which does not exist as a KP, but we were off the chart. This is still classified as a G5, but a stronger G5. So I'm not sure how reading above KP9 is really possible on the 30-minute index. Seeing KP11 for the first time, that was kind of scary. I'm pretty sure we classify that as a stronger G5, but whoever's in charge of these scales will probably have to take a look at this and see why that happened, do some research, and present it. During these prolific G5 conditions early on, blood-red auroras were seen in Central European countries. Countries like Austria were seeing bloody red images, so red in the Swiss Alps, and looked like a scene straight out of a horror film. I have never seen that before. Many other countries such as northern India, Greece, Ukraine, Italy, Cyprus, Algeria, Iran, Pakistan, Spain, and Canary Islands all reported auroras via eyes or with a high-definition camera. Into North American nightfall, the auroral band transversed across the Atlantic Ocean, and G4 to G5 conditions continued. Here is a nighttime composite showing the auroral band over the north-central United States. Many northern state reporters were reporting that the aurora borealis was actually to their south most of the night, and many southern United States and Mexico and Cuba and Puerto Rico were reporting aurora on the horizon or at least 20 to 30 degrees up. The other factor that was so great, there was minimal clouds across most of the United States. Some states still had some clouds, but they cleared out enough because the event was long enough for people in every single state to at least report aurora any time of the night. Shout out to Space WX Watch on Twitter for this graphic. This was one of the most captured aurora events in our lifetime, via phone or camera. Auroras were seen at very low latitudes via camera and overhead for most US states and European countries. Seen here on this G5 map that me and a team created is a preliminary data set of points with pictures taken from social media platforms. These platforms include Twitter, Facebook, WeChat, and many other social media sites around the world. This team took many hours of manual labor to put together a collaboration of pictures and reports seen around the world for this huge preliminary report. Now you may be thinking, well Chris, isn't there already a project called AURORAsaurus which takes aurora report maps and plots them? Yes, however, theirs uses times and verifiable points and they use it for research purposes, and mine was a preliminary map that does not have times and what the specific user is seeing. I would highly recommend checking out AURORAsaurus. It's run by Elizabeth McDonald and project manager Laura Brandt. Once again, the classifications of aurora and points taken are all preliminary and was built upon my understanding of the space environment and should not be taken as gospel or face value. If you would like to use this dataset for coding and or plotting purposes, there's a DOI on a website that I have linked in my description with a CSV/KML/KMZ file attached to download. You can use this for coding purposes. This was a historic space weather event as it beat the Halloween solar storms of 2003. These events don't happen very often, where everyone around the world can just go look up at colorful beauty thanks to the sun, and we should be grateful that technology in the modern age can withstand a G5 event. The media and scientists have been writing papers and articles for a long time that the next G5 event would be the end of technology, which turned out to not be the case. Thank goodness. The May 11th, 2024 event, known as the Gannon Event, reached a maximum disturbance index of negative 412 nanoteslas. This ranks as the top two solar storms in the 21st century, as 11/20/2003 reached a peak of negative 422 nanoteslas. The Carrington event, according to NASA, was believed to be around negative 1600 to negative 1700 nanoteslas. So hopefully, we do not see that in our lifetime in the modern age of technology. I've been tracking solar storms for the last 2.5 years now, and now I have a job in this area, in this field, and when I saw these 8 CMEs lift off the sun, I was working in Mississippi at the time. I knew I had to be there. I knew it was going to be a significant event of some degree, and I had to be somewhere up north, not in Mississippi, for this event. So I took a last-minute flight, thanks to my friend Val, who was in Atlanta and helped book half of the flight. And we both flew to Minnesota, where we drove from MSP to Duluth and just stayed in the North Shore most of the night and just watched as the aurora danced at the sky. Most of the time it was in the southern sky, southern horizon most of the time, meaning like there was stuff above us, there was stuff to the north, but the whole crazy stuff was to the south of us. Like we had major substorms at like 1 in the morning, and right as we arrived at 9 p.m, super visible. You could see it easily without a camera. So much vivid color, but it wasn't, in my opinion, super bright. You couldn't really like see a shadow, I would say, on the ground if you were like using your own reflection. I would say like the day after the May 10th, May 11th event, it was the into May 12th night, there was another auroral storm that lasted about 20 minutes, but it grew significantly brighter than the entire May 10th event. And I could see my own shadow, even with the moon out. But overall, as a photographer, it was one of the best events I've ever seen in Minnesota. I'm sure if I was in a more southern latitude like Nebraska, I probably would have seen something better. Yeah, that's my story. I think I want to add on, the AURORA project is one of the most inspirational projects I've ever worked on with a group of people. I was inspired by the AURORA. I was thinking, how many people in the world saw this event on social media and posted it? So I searched through Twitter, I searched through so many social media platforms. I'm still not done. This is probably going to be a never-ending project that you can comb through social media sources. And there's probably millions of reports out there, but I did everything in a custom way where it counted as one city versus like 100 people from one city. So there's probably millions of reports. However, we're doing custom locations. So this is a great project, and I hope that it gets used in the future.
Hi, my name is Vincent Lina. I'm an aurora chaser, and I saw the aurora during the May 10th geomagnetic storm, but not in a usual location. I was actually in India. I was in Leh, and yeah, it was pretty incredible. So basically, what happened is I was looking at all these forecasts, and I was seeing G3, maybe G4, and obviously all my friends were making fun of me because they were saying, Vince, you're going to be literally in the worst spot you could be in for one of the biggest events that we're likely to see, and this might be like a once in 20-year storm. So, sucks for you. And they were all joking about it. But I actually knew that India had seen aurora during the KP7 event back in, I think it was March or April of 2023. And so I had some confidence actually that I could catch it, or just a little bit of a glow from there. So sure enough, on May 10th, the CME hit, and it hit really hard. I was watching the AE index just pump up and just go right off the charts, and it was around 1 a.m. So I pulled up an observatory camera just southeast of me called the Hanley Observatory, and I was just watching those images come in. And once I saw a little bit of a red glow on the northwestern horizon, I ran out outside my hotel. I had to wake up the guard to let me out because it's gated. And we walked, my friends and I walked about a mile out of town to this mountain biking park. And it was still within tons of light pollution, but I got a shot of the aurora from India. And that's pretty incredible because, India, even though our latitude was, mid-latitudes, like 39, 40 degrees or something, geomagnetically it was pretty low, so it was equivalent of seeing the aurora in about Puerto Rico. So that's pretty cool. So yeah, so with that May 10th storm, I've now seen the aurora in Asia, in North America, and in Europe. And my goal in my entire life is to see the aurora on all 7 continents. So it might take another couple G5s, but I'm willing to wait. And the solar cycle's looking pretty good, solar cycle 25. So might happen this upcoming year, might happen next year, we'll see. But yeah, it was really cool to see the aurora touch so many people, and that was many people's first experience witnessing the Northern Lights or Southern Lights, and just the way that it, I don't know, enchanted millions of people. That's something that we've never seen before. And our last storm that we've experienced of a similar magnitude was back in 2003, and think about what kind of technology, cameras, social media, kind of like what stage those technologies were at. I mean, we didn't really have social media, we didn't have smartphones at all, let alone smartphones that could take pictures of the aurora. So I just think that this storm hit at a perfect time and really kind of pushed space weather to the forefront of media and into the mainstream for the first time ever. So really excited to see more activity like that happen again.
Hello everyone, my name is Hunter Fouts, and I'm so excited to be able to tell you my experience of the Aurora Borealis on May 10th through the 11th of 2024, our G5 solar storm of solar cycle 25. And for me, this was a very special event because I not only was able to go witness a fairly rare event. Seeing a G5 solar storm is pretty incredible by itself, but that also was the day that my family was in town for me to walk the stage and graduate with my bachelor's degree in meteorology. So it was a very hectic day, as you can imagine, where I spent the entire day preparing to receive my official degree and graduate and walk that stage and celebrate with my family, and then to be rewarded later that night with an aurora display like we haven't seen in a couple of decades. For me, my night was an incredible experience of seeing pillars and the Aurora Borealis directly overhead that night, and how my experience in central Iowa, just north of Ames, Iowa, how my experience was that night. And it started off right off the bat, immediately. As soon as the sun went down, the aurora was already visible. Even phones were able to pick it up, even though we weren't at full darkness. Slowly, as darkness increased, the pillars became more crisp and bright, and we noticed immediately at sundown, we're already nearly at the front aurora arc, if not it's just past us to the south. And immediately by about 10 p.m., 9 to 10 p.m. Central Daylight Time, the first substorm of the night erupted with these huge purple and red pillars that dominated the sky to the north. And even though there was some green aurora, it was fairly dominated by that type of color, reds and purples. As the night progressed, we then went into a recovery phase, but that arc continued to surge southward to now being directly overhead, where the second substorm of the night fired off at about midnight, maybe just a little bit past midnight, where it went from very flickering, pulsating greens to suddenly very huge pillars of light, generating all different types of colors I've never seen with aurora before. Not just the regular greens and purples and reds, but we were seeing oranges and pinks and blues, just colors that I never thought I would ever see with the naked eye during the aurora. I didn't even know some of those colors were even existing. Whether they were just optical illusions of two different types of aurora pillars over top one another, I don't know, but it was just a beautiful, colorful display of aurora, and especially being able to be underneath a pillar and look up and watch pulsations go up each individual pillar directly above my head. Just a wild experience. The next 3 or 4 substorms were incredible, but as the Earth started to slowly move towards sunrise in my location, and we started to move out of the Earth's shadow aloft, way high in the atmosphere, those purples turned to deep, vivid blue aurora colors. Pinks and blues were the dominant colors at that point, up until about 4:30 a.m. when the sun slowly started to rise and we started to increase sunlight. But it was a constant night of just insanity of color and pillars and flickering and pulsations, just every type of aurora, except for a Steve. Aside from that, I didn't witness a Steve that night or a SAR arc,
but we had everything else. It was such an amazing experience, something I thought I would never have living so far south here in central Iowa, to see the aurora directly above my head. What an amazing experience, what an amazing night, and I can't wait to see another storm like that around here. Thank you.
Yeah, so I was actually flying to Denver, Colorado on May 9th, right before the show, and I knew the flares were coming, so I was getting really excited. So I did ask around for some rides, but sadly none were available, so I was really, really bummed that I was going to miss the biggest show in two decades, even though I was in downtown Denver. I still wouldn't know I would have a chance to see the Northern Lights. So around 9:30 or so, now after sunset in Colorado, I went up to the hotel roof. I couldn't really see it. Then I was looking at some data come in, and it looked pretty good. So I just waited up there, and then with my camera, I took a long exposure, and boom, I saw it. I faintly saw it with my naked eye. Again, this is from the downtown Denver, all the city lights. So even with all the light pollution, I was able to make out the Northern Lights, which is really special for me because it was the first time that I saw them, as many saw the lights for the first time. I did as well in Denver. So it's really cool seeing the Northern Lights even in a city. So that's pretty cool.
Hey, my name's Val. I'm a space weather enthusiast from Atlanta, and this is my account to the epic May 10th G5 event. So starting on May 9th, I'm on a flight home from New York reading about this large sunspot that's been flaring all day, and find out it's launched 3 CMEs at us in rapid succession, and they're gonna hit tomorrow. I'm thinking, holy crap, I gotta get home, grab my camera, and head north, because this could be huge. And later I saw a post Chris made wishing he could go up and see this. And I reach out, I'm like, hey, you really want to go see this? And let's go. We can share the cost of everything and make it happen, because this could be the big one. So we plan to meet in Minneapolis the next day, and I'd fly standby up there. Meanwhile, 2 more CMEs get launched at us. In the meantime, now I have 5 of them on the way. So next day, the 10th, we get to Minneapolis and the CMEs arrive. All 5 of them combine together and hit us all at once. The data was absurd, and the wind speed was like 800. The magnetic field went to like 66 to the south. Instantly, we were at G4 conditions and G5 not long after. The reports were coming in from Europe. The skies are miraculously clearing off, and we just waited for the sun to go down as we drove towards Duluth. So we ended up at Split Rock Lighthouse along the North Shore, Lake Superior, and the aurora was out as soon as it got dark. Like within an hour, it was just wall-to-wall coverage. I've been watching aurora for 8 years or so, and I've never seen anything like it. The vibrance of the colors to the naked eye was unmatched, especially the reds, pinks, and purples. You know, the ones that are usually harder to see than the greens. Those were the ones that were really the most spectacular that night. It spanned the whole sky. Oftentimes we had to look south over Lake Superior to see them, which made for some awesome shots. Other time you could just watch them dance overhead. The display went all night, just substorm after substorm. We finally call it a night around 3 a.m. The event lasted into the next day, the 11th, and that night was a great show in its own right, but that first night was one for the ages. It's one of the most incredible natural events I've ever seen.